All right, tonight we will continue our types of motion. We're done with translational motion. I made a video of that. You can check that one out. And then we will be discussing more about rotational motion at this particular moment or whatever time you're watching. Okay, so when we say rotational motion, it is when an object turns or spins about a fixed axis. So when you have a fixed axis and then that object is turning or spinning, that's rotational motion. Just like these examples here. Okay, we have a spinning wheel. This is the fixed axis, and then it rotates in whatever direction. We have a fan. This is the fixed axis, and then it will rotate in counterclockwise or clockwise direction. And we also have a fixed axis of the earth. How will I supposed to draw it? But yeah, there's an axis on that earth that it will rotate in a certain direction, and there is a fixed axis at the center of earth while it rotates at certain direction. Okay, so that's rotational motion. Bottom line, when there will be turning of the object or spinning of the object at a fixed axis, definitely that's a rotational motion. So we will have the North Star of our video about translational motion. The North Star, the object, or let's say the rigid object, if you could still recall, rigid object, no stretching or no stretching. Is my spelling correct? Stretch. Yeah, stretching, no bending or no deformation. Now, the object is not just moving forward. It's not moving forward because that pertains to translational motion. It is rotating around a fixed point, and we call it axis, right? And there will be a fixed point, and it's rotating. Definitely, that's a translational motion. It has a full rotation. Let's delve deeper to this type of motion. We're still talking about rotational motion here. Okay, in rotational motion, the whole rigid object rotates together. All the points there rotates together. Just like translational motion, it's just that translational motion, these points are moving in a back and forth, one direction. In this case, it's moving in a circle. Every point, when we are discussing about one point of that rotation, okay, of a rigid object, moves in a circle. For example, we have this fixed, I will use another color. That's the fixed axis. And then we have a rotating object there. It rotates. And if ever we will have some point here, it says every point on that rigid object moves in a circle. So this point here will have to move either clockwise or counterclockwise, moving in a circle, not in a straight line. It rotates through the same angle. We will have to use this symbol here. It's theta. It represents the, or sorry, it represents the angle measured. Okay, because we're dealing with circles, so there will gonna be like angle there, and yeah, in specific time, it rotates in the same angle at a specific time. The point there of a rigid object. We have a term angular motion. When you say angular motion, the motion is rotational and through angles. Let's say, for example, I have a very simple uh, illustration here. That's the axis, and if ever the object moves from point A to point B, so that's gonna be the motion. It's clockwise. So this is our angle. So that motion rotating with through an angle, that's angular motion. Same for all the whole rigid body, not just one single point, but the whole points there, they move at the same angle. Okay, when the object rotates at an angle, that's what we call the angular motion. When an object rotates at an angle, and all the points there in a rigid body, they will move at the same angle. So talking about a whole rigid body, the body rotates together again and again. All points turns through or spins through the same angle at the same time. So all the points there will move or will rotate at the same angle, and also same angular displacement, angular velocity, and angular acceleration. We will be knowing these variables here that pertain to rotational motion. In our previous video, translational motion, it talks about linear displacement, linear velocity, and linear acceleration. But this time, since it moves in rotational manner, we will be using angular, the word angular to describe these variables. Okay, so what about, there's a question here. Sorry. What about speed and velocity of each point? Okay, although the angle is the same as always in a rotational motion, all the points in a rigid object will move uh, in that same angle together. Okay, but there is a difference when we will be viewing speed and velocity, not the angular speed or velocity, but the speed itself or the velocity itself. It varies, not the same, depending on the location of the point from fixed axis. So I will be giving a certain illustration for that. Okay, again, the angle when this all points from of the rigid body will move, it will have the same angle all throughout that rotation. But when we will be discussing, or when we will be talking about what's going on with the speed of that single point there, or velocity of the single point as it goes around that fixed axis, it's not the same. It varies. Okay, I'm talking about speed and velocity, or linear velocity, or linear speed. I'm not talking about the angular thing here. I'm talking about the linear thing. Okay, so I have here, I hope it will help. Let us visualize the different variables for rotational motion. The different variables, we have angular velocity, angular displacement, angular acceleration. Okay, this variables are the same when this rigid object will move in a rotational manner. Okay, so let's say I have it here. The object, or the object will move from A to B. Okay, and we will be creating this angle theta here. Remember, this is the angle theta. It is being formed when there will be change in location of a certain point, or the points of this rigid body. So another thing here, it changed from A to B. So that's the direction. And this is what we call the arc length. Or in this video, we will be using the angular displacement. There's a change in position. And of course, with respect to the angle formed here. Okay. And that's the displacement here. Now, this wheel turns at specific time. Okay, there is of course time, let's say in seconds, as this point A move in this position, or rotates in this position at specific time. Remember the formula, displacement over time. What is that variable in our physics topic? It's what we call velocity, but this time we will be dealing with the angular displacement, right? Angular displacement. So therefore, the velocity we are talking here, to be specific, it's called the angular velocity because the object spins or rotates. Okay, so the change in position, or the angular displacement over time, that's the velocity there when the object is moving from one point to another over time. And of course, in that case, since we have velocity here, let's be specific since we're dealing with rotational motion. We have angular velocity. Okay, and in that sense, we can also, when velocity is changing, therefore we have angular acceleration. It's non-zero if velocity is changing, meaning there is a value of acceleration. It's not zero, but when velocity is not, the angular velocity is not changing, therefore angular acceleration is zero. Okay, I always remind you about that. Now, that's it. I hope you understand how to visualize what's going on. This angular term here, we will be using this to describe that the displacement or velocity and acceleration is happening when the object is spinning or rotating. So we will be using this term for rotational motion. Okay, but going back to the question earlier about linear velocity or linear speed, when we say speed, it tells us how fast the rotation. And when we say linear velocity, it tells us how fast the rotation, but this time with direction because it's a vector. Okay. And a note, focus on one point only when you will be describing the linear velocity or linear speed in a rotating object. It might be confusing because it's rotating, but we're trying to observe about what's going on with the linear velocity or linear speed. Okay. And yeah, just focus on one point, single point of that rigid body, not the whole body itself. Because when you're focusing on the whole body rotating, so yeah, the angular displacement, angular velocity, angular acceleration in that specific time, same, same angles as well. So in that case, let's pick one point here. I will use this rotating wheel. Let's say the rotating wheel is moving, and this is our axis, a fixed point. And let's say we have it here, this position here, point, this radius A, it's going to this particular point. So again, this is our, you can still recall the arc length, or our angular displacement. And we can have an angle here, angle theta. Okay, I'm gonna remove that one. So we will be picking one point here because we will try to find out what's the linear velocity or speed if the point is from near from axis or away from axis. Let's have the point here and point here. Of course, they will, this point will move in this uh, position. It's changed in this position as well. Okay, we have, let's say, point, I will use another color, point X and point Y. So which one has the fastest speed or fastest velocity between the two, X or Y? So try to find out. If this X point here will move, it will rotate in tiny circles, while Y will rotate in a much bigger circle. So which one point travels the longest in same time, for example, in same time, right? Which point travels a lot of distance or displacement, which point travels the less distance. Okay, now let's have the point near the axis. So this is the point near the axis. In that specific time, it travels in a small circle. So small circle means less distance traveled over time. So in that case, speed or velocity is slow. Why? Because in that specific time, there is a less distance being traveled. Remember, speed is equal to distance over time. The more distance traveled, the higher. The more distance traveled, the higher will be the speed. Okay, in same time, away from the axis. Let's say this point is traveling or rotating with more displacement or distance. So therefore, it travels in a larger circle compared to point X. This is point X. This is point Y. Then meaning distance, more distance traveled over time. In that case, the speed or velocity is fast. So the bottom line, I will put it here. I will add this one here as one of the things that you need to remember when you will be describing the linear velocity or speed. Same thing, but velocity has direction. This is the linear velocity fast if the point is far from from axis, and it's gonna be slow if the point is close to axis. Please remember this one when we will be describing linear velocity. That's it. And another North Star here, I want you to know that again, angular motion, the object rotates through angles. And the angle, when this rigid object will move, all the points will have the same angle. All right. And at instant time. Okay. Let's say, for example, this is the axis, and then that thing will will move at certain time in this direction. So all the points here will be traveling at that same angle in an instant time when all the points. Okay. Yeah, that's it. Same angle for all points. In linear motion, again, linear motion is not angular. There's no such thing as angle being involved. That in linear motion, it depends on the distance from the center. We will be focusing on single point only of that rigid object. So when the point is near to that axis, it will have lesser value or magnitude of linear velocity or speed. But if the object is far from it, so from the axis, so it will have larger value of linear velocity or linear speed. That's it for this video, and I hope you learned something about rotational motion, and I hope you will never forget to support this channel. Okay, also support this channel for me to upload more videos of it. Thank you so much, and I hope you learned something. See you next time.